Let's take the limit of these two geometric sequences. So this first one, let's just write out the terms to make sure that we understand what we're dealing with. So the first term in this sequence is negative 0.2 to the 1. The next term would be negative 0.2 to the 2. The next term would be negative 0.2 to the 3, etc. So this geometric sequence is found by repeated multiplication by negative 0.2. And then let's look at the second sequence just to get a sense of what it looks like. So we're going to start at 1, and then when n is 2, and then when n is 3, etc. So both of these are geometric sequences because we attain the next term by a common multiplication. So the common multiplier in the top one is negative 0.2. The common multiplier in the bottom one is pi. Now this brings us to a couple of basic facts. When you take a number, let's just take a number like 0.5, less than 1. When you take a number less than 1 and you multiply it by itself, it gets smaller. And if we repeatedly do that, if we keep multiplying by this 0.5, which is less than 1, the number is going to get smaller and smaller and smaller. It's going to get closer and closer to 0. Similarly, if we take a number that's larger than 1 and multiply it by itself, we are going to get numbers that are increasing in magnitude. So if we have a base value less than 1 and we do repeated multiplication, we are going to approach 0. And if we take a base number that's larger than 1 and do repeated multiplication, that limit will be infinity. So this top sequence here is going to 0. And this lower sequence is going to infinity. Let me point out one nuance here. If our common ratio is a negative number, so let's just say it's negative 0.5, we are still going to end up with a limit of 0. It's just that the way that 0 is approached will be through both positive and negative numbers. So here there is going to be an oscillation that will approach 0. So in your mind, if you wanted to, you could think of something like this. So if we started at negative 0.5 here, if we wrote this as a continuous function, you would think of this as the behavior. The limit will still be 0, but it will be through both positive and negative numbers. Now, if our common ratio has a magnitude bigger than 1, but it's negative, we're going to have a slightly different scenario. The limit will still not exist, but it's going to not exist in a way that we can't be concise. All we can say is that this limit does not exist. So if the magnitude of r is less than 1, the limit will be 0, regardless of whether it's positive or negative. And if the magnitude is greater than 1, the limit will not exist. But what we can say in the case in which r happens to be positive, so it's greater than 1 and positive, what we can say is that the limit will be infinity. But if r happens to be negative, all we can say is that the limit does not exist.